This is a new Toro reel. It's over 10 years old, I believe, but it's new. It's still got the paint on the land area of the blades. It's been sitting in a corner of my shop for a long time, collecting dust. I decided to measure the diameter using a surface plate. This is the number that's engraved on the reel. This is Toro specifications for a new reel, diameter 5.060. So what I did is I rested the reel on the surface plate. Like I said, there's paint on the land area, so there's a thin layer of paint between the reel and the surface plate. So I picked one of the journals. I picked, I think it was the seal journal, the one that's adjacent to the end of the reel. I measured from the plate to the top of the journal. And I rotated the reel and measured in several different spots on each end. And I got very consistent readings. I think the largest one that I got was 3.192, and most of the readings that I got were 3.190. So none of the readings that I got varied by more than 0.02, and it was very consistent on each end. So that measurement there, I'm calling it the plate to top of journal. Then I measured the journal with my calipers, 1.312. Half of that is the radius of the journal, 0.656. That gives, I subtracted that from the first measurement. That gives me the radius of the reel, 2.534. That's from the axis to the plate. Multiplied times 2 gives me the diameter, 5.068, which includes the paint. I think if I were to scrape the paint off, I would get something very close to factory spec. Then I measured the diameter with a pie tape, and I did the recommended procedure to multiply, I think, by 1.014, I think it was, and that gave me 5.093 on both ends with the pie tape. That would be measuring here to here. That's a little bit larger than the actual diameter. It's about 25 thousandths larger with the pie tape. And I'll do another video and demonstrate how I did this measurement. There's several different ways to do it with a surface plate.